Hello there, Wildcats. Welcome to your geometry class. Today we are going to talk and discuss about translation. A translation, by definition, it is a transformation which slides a figure a fixed distance in a given direction. In a translation, all of the points move the same distance in the same direction. A translation is called a rigid transformation or isometry, because the image is the same size and the same shape as the pre-image. So your translation, the shape on your translation will not change. All right. So it's a lot easier if we are going to apply a given rule on your translation. So let's proceed with the first example that we have on your screen right now. Now, on this example that we have here, we have T stands for translation, and then we have 7 and -4. Your 7 here, this is the horizontal movement. Meaning it's the movement along your horizontal axis here, which is your x1. And then we have your -4 will be your vertical movement. So on this situation, all of the points move horizontally 7 units, and then all of the points also will move 4 units vertically. But the question there is that are they going to move to the left, or are they going to move to the right, or are they going to move to up, or are they going to move down? Now there are clear indications and symbols that we need to follow in there. So example, the symbol, it's take a look at if it is a negative or a positive number. So if it is a positive number, it moves up and it moves to the right. Okay. If it is a negative, it goes to the left or it goes down. Okay. So in this situation, if I'm going to graph this, it says there the translation of the given image, pre-image triangle EFG is it moves horizontally 7 units, and then it moves vertically 4 units. So let's start with the E. So you have to do the movement of each of the point. All right, so for E, okay, the ordered pair for E is -5, 4. Now your E prime would be -5 plus 7, because it's a positive 7, and we have your Y would become 4 minus 4 because of the -4. Sir, Mr. Where did you get 7 and -4? It's this translation here. It moves horizontally 7 units, and then it moves vertically 4 units. So your E prime now would give us, E prime is, we have 2, 0. Okay, so this is our point E prime, which is 2, 0. So I can graph that. We have E is 2, 0. So this is our E prime. So if you are going to look into your E prime, okay, so if you check if the movement is right, 7 and -4, so you count 1, 2, 3, 4, 5, 6, 7, and it's negative, so it goes down 1, 2, 3, 4. So it's a lot easier if you know how to read those rules that we have there. So 7 to the right because it's a positive 7, and then 4 down because it's a -4. All right. While your we have EF. So we have F is the point on F is -1, +5. So your E prime would give us -1 plus 7 and we have 5 minus 4, which will give us your f prime would give us negative 1 plus 7 will give us 6, positive 6, and then 5 minus 4 is 1. So you can graph 6, 1, which is the location of your f prime. So your f prime is 6, 1. So it's here. This is your f prime. Take note that your transformation, I'll repeat, on transformation, we are not changing the measurement and the size of the object. We are just only translating it, meaning we are moving it from left to right, from up and down. And then for G, maybe I'll just use green color here. So for G, we have the point on G is negative 2, negative 1. So negative 2, negative 1. Thus, your E prime now, or G prime, sorry. This is F. I'm sorry about that. F prime. Just erase this one. This is F prime. Sorry about this. All right. So your G prime would give us negative 2 plus 7. Okay, and we have negative 1 minus 4, which will give us the G prime of, okay, negative 2 plus 7, it's positive 5, and we have negative 5 on your negative 1 minus 4. So this is your G prime, and then I want you to plot the points where your G prime is located. So we have positive 5, and then we have negative 5. It's here. So if you graph them, so negative 5 is here. So this is now your G prime. Okay, and then you can now connect those points that you have there, so you can see your translation. So I'm going to connect those points. All right, so it's a segment. There you go. And maybe I'll just put black color. So this is now your image here. Sorry about that. It must be a solid one. Maybe I can just use a red one. Red. There you go. And then from here, there you go. So this is now the translated of pre-image that we have. So this is now your image. So you translate your image 7 units to the right and 4 units down. Okay. Next example is we have the difference now is we are going to create a rule to this. So the graph, the pre-image and the image is given. Now what are we going to do is we are going to make a rule based on the transformation that is described on the graph. So use one pair of corresponding vertices to determine the change in horizontal and vertical direction between the pre-image to the image. So if I'm going to choose S, so take a look at the your S here. So maybe I'll just use blue here. So S is 1. So from here to there, that's 1 unit. Okay, 1 unit to left. Okay, and then how many units to down here? So I'll just use maybe green. So how many units? That's 1, 2, 3, 4. So that it's 4 units down. Okay, so basically we are looking at both are negative. Okay, because if it is a positive, it's moving to the right. If it is negative, it goes to the left. If it is positive, it goes up, and then if it is negative, it goes down. So based from there, actually you can actually check with your T. That's 1 unit, and then 1, 2, 3, 4. It's the same. So this is 1 unit, then 1, 2, 3, That's 1, 1, 2, 3, 4. It's the same with U, the changes on U. How about V? So that's 1 and then 1, 2, 3, 4. So it's 1 going to the left and then 4 down. So you can now say the translation for this one is that translation of, okay, -1 and -4 of your given STUV, okay, so this is now your translation rule. So maybe I can just remove the STUV there. So the translation rule will be this. Translation rule is 1 unit to the left and 4 units downward. All right, so that is all about translation. So I'll just wanna do quick summary on your translation. Is that your translation is a rigid transformation. That means that your the image will have the same size, okay, and then your image also will have the same shape as the pre-image. So you're just translating, you're just moving the image from, and make sure that all of the points will move together, all right, at the same translation rule. All right, thank you guys for watching this video, and we'll see you next time, and good luck and have a good day. Bye bye guys.